Howdy, Internet. I've cleared a space on my fairly terribly messy workbench because I got a new toy in the mail today. It's a transformer. It's an oil burner transformer. These are, as far as I know, correct me if I'm wrong, I'm not a heating system technician, but as far as I know, these are used to ignite oil burning combustors used for things like water heaters and air heaters and whatever other sorts of things you may need to heat with oil. And I think the intent in its intended purpose is really just to throw an arc between 2 points. They're vaguely similar to neon sign transformers. This one is spec'd at 10,000 volts and 23 milliamps. Maybe I can zoom in on that label a little bit. Yeah. So 10,000 volts at 23 milliamps. Pretty significant amount of high voltage coming out of this thing. Definitely not not to be treated lightly or used as a toy by someone who's not fairly experienced in handling high voltage and safe practices around high voltage. So obviously I need to test it out, and the best way to do that is to strike some arcs here. So I've cut up some coat hanger wire and made a couple little horns that should act as a nice Jacob's ladder. I say should, but I actually know it will work because I've tested it before I started filming. But nonetheless, let me hook up my ground lead. And this transformer is actually, the center tap is grounded, so theoretically I'll have 5 kilovolts coming here, 5 kilovolts coming here, reference to this ground. I've got my big red rocket high voltage probe, and I'm going to do a measurement on there, because why not? But for now, let's just fire this thing up and see what it does. Looks pretty good. So, I've safely unplugged it. I always, when I'm working with things like this, I like to keep the end of this cord in view, just to ensure that I haven't accidentally left it plugged in without an arc running, because really, when it's not arcing over like that, it's very hard to determine if it's energized or not. So it's just a safety practice kind of thing if you're working with this sort of equipment. There's no capacitors or anything in here, so I don't have to worry about any residual charge. But I'm going to spread these electrodes out a little bit just to get to the point where it won't arc over, and I'm going to use my high voltage probe and see how much this thing is actually putting out. Alright, so the transformer is energized again. I have my probe here, and as I move the probe closer to the electrode, you can actually see that the, I think it's the E field around these electrodes is propagating through the air onto the tip of that probe, and I'm showing around 400 volts at about a centimeter away, just going straight through the air. There's no contact here. This probe is it divides by 1,000, so anything that shows up on the multimeter display, essentially 1 volt equals 1,000 volts. So if I touch this to the terminal here, looks like I've got about 4.3 kilovolts over there, and I should have roughly the same over here. Yep, 4.3 kilovolts over here. So it's actually running a little bit low. I don't suspect that's the transformer's fault. I think I just have really terrible power in this building. I haven't actually measured my line voltage, but I would guess that it's probably somewhere around 110 volts. I'm going to unplug the transformer again. It's that little spark when I unplugged it from the, I think it's the back EMF when the magnetic field around the coil collapses. I think it will actually be a fair amount higher than what the transformer will typically run when it's just sitting there. So I am safely unplugged here. And I'm going to adjust my electrodes a little bit closer so we can get that arc going again. Unfortunately, I don't have any high voltage PPE gear like gloves or even a proper hot stick, so I'm not really going to do much of anything with this transformer aside from watch it look pretty right now. I really do need to invest in that equipment. Oh, not good enough. Nope, not quite. Alright, there we go. Well, now it appears I have my electrodes a little bit too close, because I'm just getting a stable arc at that point. It's not propagating up like it should, but oh well, whatever. See if I can tweak it just a little tiny bit more. I appear to have messed up the geometry of this thing at some point. There we go. These things are actually really finicky to get the arc to propagate properly. With a fairly substantial amount more effort, I could probably get that thing going all the way to the top and bowing out. But I'm really just playing around with it at this point. So unplug it again. It is safe. Connectors in view. And I purchased this transformer with the intent of building a charging system for these very large and rather scary capacitors. They're 196 microfarads at 2.3 kilovolts. I think that comes out to around 400 joules, and I have 4 of them that I'm probably going to hook up in a sort of series parallel, actually probably a configurable series or parallel bus bar arrangement, so that I can get the same amount of total energy in the discharge, but at different voltage levels depending on what I want to do. Higher voltages is good for some things, and lower voltages is good for other things. So I'll post updates as I get that project sort of constructed. I have quite a bit of work to do around that. I have high voltage relays cost a fortune, so I'll have to build my own, and unfortunately I don't really have the tools to easily do that. But anyways, I'm sure I'll find a way. I've also got some high voltage diodes coming from China, so that's a fairly essential part of charging capacitors of a transformer. Anyways, just a fairly quick little video of this thing because arcs are fun, high voltage is fun, but if you're not experienced with it, I don't really advise you to idly play around with it, because it actually is fairly excessively dangerous. And that's about all I have today. Just some arcs.